This is going to be objective 4. We're going to multiply and divide rational numbers. So what numbers are we going to be multiplying and dividing? They're rational, whole, integers, repeating decimals, fractions, mixed numbers. Percentages are rational, but we won't actually be adding or multiplying and dividing percentages. But any number you can take and rewrite as fractions. So we're going to be looking at mixed numbers. We're going to be looking at whole numbers. We're going to be looking at positives and negatives, integers and decimals. The good thing about, I think, in my opinion, that multiplying and dividing is easier than adding and subtracting. So here's the good news. I think today is going to be easier than yesterday. Would you agree with that statement? Because adding and subtracting gets a little confusing occasionally. You got to really keep straight your adding and subtracting rules. Sometimes when it says this plus this, doesn't mean you really add, right? And sometimes when it says this minus this, doesn't mean you really subtract. Sometimes you add, sometimes you subtract. You got to look at the signs, whether they're the same or whether they're different. Well, the good news is here is that if it says to multiply, we're actually going to multiply. And if it says to divide, we're actually going to divide. So all you have to keep straight is the signs. Does that make sense? So, everybody know the rules for when we multiply and divide? Very good. A negative times a negative is a positive. What else? What if they're two positives? So you're telling me if they have the same sign, two negatives or two positives, the answer is going to be positive. Oh, so you already know your rules. So here they are. If they have the same sign, a positive times a positive, or a negative times a negative, then the answer is going to be positive. What if you have different signs? Then it could be negative or it will be negative. Will be, yeah. If you have different signs, a positive times a negative or vice versa, a negative times a positive, you could put division in there as well. The answer is going to be negative. And there's no like except cases, you know, this is it. These are the rules, okay? So all you got to do is remember. So I think you'll find today fairly simple. These rules you'll be fine with. When does it get a little tricky? How many thought the adding and subtracting rules, you're okay with adding and subtracting? I mean, you actually have to think and remember, but you're okay with the rules, right? Same sign, different signs. And we got used to, we're getting better with the not copy, change, changing. A little bit better, okay? So those rules are okay. And I feel like you're going to be okay with today's rules. So when does it get tricky? Right, and when you put all these rules together on one page. So your quiz next week is going to have adding, subtracting, multiplying, and dividing on it. And so the thing of it is just remember, keep straight, don't forget the rules for adding and subtracting. Does that make sense? And when I teach you the rules for multiplying and dividing today, make sure you keep those separate from your adding and subtracting rules. Does that make sense? If you'll keep the two sets of rules separate, then you won't get confused when I throw them all on one page together. Does that make sense? Just make sure to keep them separate. All right, so let's just look at a couple. Oops, this still has some work from first block on here. Let's look at some examples. Okay. So I'm going to do this like a part 1 and a part 2 too, as well. What does this example say? 4 times negative 6. Again, you know, we use parentheses to mean times. When it's side by side, it means multiplication. So if I were you, part 1, I'd multiply the numbers. 4 times 6 is 24. And then part 2, go back and figure out the sign. A positive times the negative is a negative. Okay, part 1, part 2. Okay, how about example 2? Negative 10 times negative 5 is positive, right? A negative times a negative is a positive 50. Everybody okay with that? Let me know if I go too slow. Negative 4.9 times negative 8. If I were you, let's, part 1, part 2, drop your signs, and let's just multiply the numbers. So 8 times 9 is 72. Carry your 7. 4 times 8 is 32. Plus 7 is 39. How many decimal places? Once over. And someone said, why didn't you line up the decimals? Why didn't you make that 8.0? Because we're not adding. Remember, when you add and subtract, here's where you got to keep it straight, right? When you add and subtract decimals, you make them decimals and you line them up accordingly. But when you multiply, you don't have to line them up. You just count the places, okay? If you made it 8.0, actually, no, I don't think it would, because you'd have a 0, and then it'd be an extra place, and you move it twice, and it'd still be the same. So, very good. So 39.2. And then part 2, a negative times a negative is a positive. Okay, so don't forget part 2. All right, let's go to some fractions. How do we multiply fractions? And again, I would, part 1, drop your signs and just multiply and figure out your answers. So do I have to have common denominators to multiply? No. Do I cross multiply? No. Do you guys know when somebody in first block asked me, they said, Ms. Corn, when do you cross multiply? Because I've had somebody, like at least 2 to 3 people in every block that every time we start working with fractions, they're trying to cross multiply because that's what we like to do, right? We like to cross multiply. Okay? Let me just show you really quickly. When you cross multiply, it's when you have, first of all, an equation, which we don't have an equation. We're not dealing with any equations. 1 over 9. You would cross multiply if you have a fraction equaling a fraction or a ratio equaling a ratio, and you would cross multiply and set it up. Does that make sense? So we are not doing that, okay? But what we can do, and I'm not sure, some people said their elementary teacher told them little tricks that you could like fish or do something, but what I'm going to do is you don't have to have common denominators. So option 1, you can just multiply straight across, but what do you have to remember to do? Simplify and then simplify. Or you can cross reduce. It's not the same thing as cross multiply. You can cross reduce. And I like to do that because the minute I reduce, the minute the problem becomes easier, and then that way I don't have to worry about reducing at the end. Does that make sense? So if you like to multiply, how many like to multiply first and then reduce? Like everybody. And that's fine. You can do that. I'm going to do it this way. So does 3 and 5 reduce? No. Can 2 and 6 reduce? Yes. The 2 can become a, and the 6 can become a. Now multiply across, what will I have? 5 over 9. Okay. I feel like if I multiply straight across, I forget to reduce. Anybody feel that way? Anybody like to cross reduce with me? Yes. People on my wavelength, but it's okay. You do it however you, as long as you're reducing and getting the correct answer out, you can do it either way. Okay? Well, I'm not done yet. I've only done what? Part 1. Austin says, don't forget part 2. A negative times a positive is a negative, and that's key. Don't forget part 2. Thank you for that, though. Okay. So example 5, 12 divided by negative 4. So again, drop your signs and just divide. 12 divided by 4 is 3. And then part 2, a positive divided by negative is a negative. Everybody okay? We had some whole numbers, we had some integers, we had some decimals, we had some fractions. So far so good? Okay. Let me erase real quick too, sorry. What do you see that we're going to be doing? Long division. How many just went, oh man, long division. Here's the thing. Why don't we like long division? Before I even put the examples up, why don't we like long division? Because it's long. Well, here's what I vow to tell you. Okay? We don't like long division because we divide, and we add a decimal zero, and we divide again, 0, divide again, 0, divide again, 0. And before long, we're off our paper and our problem's this long, right? And we like, oh my gosh, right? So I vow to you that you will not have anything in this class over 2 or 3 decimal places. Does that make sense? So just work it out. It's only going to go 2 or 3 decimal places. And if it goes further than that, what will the directions say? It'll say round to the nearest tenth or hundredth. So if it says, like I think the ones in your book say round to the nearest hundredth, so how many places do you go out? You got to go out an extra third place and then round it back to the second, right? Does that make sense? So you'll have to go out 3 places. There is one example that we are going to work in the book that does go forever and ever and ever and ever, and I'll remind you of it, okay? Just remember, just go out 3 places and then round it back to the second. So you won't have to go forever and ever and ever. Does that sound good? Huh? No, it's not pi. All right, here we go. 4 more examples and we're done. Let's just do a couple of these. So, drop your signs. 39 divided by 3 is 13. How many would not have known that? Okay, so let me tell you. How do we put it in the house and actually divide it? Like if we don't know it by hand, we got to put it in the house and divide it, right? How do you remember which one goes in the house? The first one. Very good. The first one always goes in the house. So 3 into 39. So 3 goes into 3 once. 1 times 3 is 3. That's a 0. Bring down your 9. 3 goes into 9. 3 times. That's a 9. Remainder of 0, so you know you're done. Okay? So 13. Any questions about the first one goes in the house? Okay? And part 2, a negative divided by a negative is a positive. Yeah. Okay? So let's review how to divide fractions. So, how are we going to divide? Part 1, I would drop your signs. How are we going to divide, though? You only have to have common denominators when you add or subtract. But there is a little rule that you do have to remember when you divide. How do we divide? Copy, change, change. Or copy, change, flip, or keep it, change, and flip it. Or the technical term would be to multiply by the reciprocal. Okay, so here's what I would do. Copy the first. Change it to multiplication, and then 5 over 6 will now become 6 over 5. And again, to multiply, can you multiply straight across? Sure, but what am I going to do first? Reduce. 3 and 5 reduce. 6 and 4 reduce by 2. So the 4 can become a 2, and the 6 can become a 3. Then when we multiply across, 3 times 3 is 9 over 10, and a negative divided by a negative is a positive. Any questions on multiplying by the reciprocal? Okay, 2 more. Ooh. How do we divide mixed numbers? I should hear 2 things. 2 things that's got to happen. Name one. We got to make the mixed numbers improper. That's 1. And then what? Copy, change, change, or copy, change, flip, or multiply by the reciprocal. Can we make mixed numbers and copy, change, flip all in the same step? No. I would not do that because what's going to happen? You're going to get something mixed up. You're going to forget to flip something, or you're going to flip something you're not supposed to flip, and it's just going to get all jumbled up. So here's what I'm going to tell you. As far as showing work, this one needs to have several steps to it. Step 1, drop your signs. Let's just change to improper. 3 1/5 becomes 16 over 5. And again, I'm not changing the multiplication yet. All I'm doing on step 1 is what? Making improper. Okay? 2 1/8 becomes 17 over 8. And again, I have dropped the signs. Part 2, I'll do the signs in a minute. So now, what do I need to do? Copy, change, flip. Good. So copy, change it to multiplication, and then flip and become 8 over 17. Okay? Can I cross reduce? 16 and 17? What can go into 16 and 17? I don't think there's anything that can go into 16 and 17. Can anything go into 5 and 8? No. Can this reduce? 16 over 5. Can 8 over 17 reduce? So here's the thing. How many of you, when you get really large numbers, you're like, I don't know if this can reduce or not? And you have to sit there for a while and look at it, right? And try a couple different things. How many, it takes a while, right, when you get big numbers. So here's what I'm going to tell you. If you cannot reduce crossways, that's why I always check crossways first, and you cannot reduce the normal way, up and down, what do you know about your answer? It's not going to reduce either. So that should help you some. Does that make sense? So here we go. You work it out for me. 16 times 8 is, Lindsay says 128. Do we agree? We'll get a second. Do I have a second? Lindsay made a motion for 128. We got a second for 128. All those in favor of 128? Aye. Oh, come on. Y'all got to be fun with me. Okay. How about 5 times 17? We have an 85. Do I have a second 85? All those in favor of 85? Sure, why not, right? How many didn't do it and you're like, sure? Okay, so can I leave it like this? Yes. 128 over 5. Am I finished? Over 85. Why not? I haven't done part 2. Make sure, if you can't remember to keep your signs and do your signs, you ought to do this, like do a 1 and a 2 beside your problem. Part 1, complete, check. Part 2, make sure you check your signs. You know what I mean? Like, keep yourself a tally or something that you've done both parts. A positive divided by a negative is a negative. Okay? Everybody okay with mixed numbers? Everybody okay with copy, change, flip? Okay. One last one. Just 9. All right. What are we going to do to divide decimals? Someone said, change them to fractions. And I'm like, well, I guess you could. You could make that 5 1/2. And then you could make it improper. And you could make 0.8 what? 8/10 and 4/5, and then you from there could cross reduce or copy, change, flip, and divide and all that good stuff, and that would work. But I'm actually going to divide a decimal. I think it's important to remember how to divide a decimal. So we're actually going to put it in the house and divide it. So which one goes in the house? So we're going to say 0.8 divided into 5.5. Who can tell me about dividing decimals? Go, Hannah. Very good. As many as it can go. And in this case, it is just one time. We're going to make the outside a whole number. Everybody okay with that? So I move this over once, and I got to move this over once. I'm going to actually rewrite it. What's it actually saying? 8 into 55. Okay, so here we go. It's only going to go out a couple places. I promise you. Okay, so 8 goes into 55. Well, the first one's 0, so I go to the 55 6 times. 6 times 8 is 48, and that is, when we subtract, we get a 7. Now, in 3rd grade, you did R7. Why did you do R7 in 3rd grade? That's what you have. It's your remainder. But why did you do that in 3rd grade? Because you did not know. You didn't know how to keep going, meaning we didn't know what? We didn't know decimals. Does that make sense? You didn't know decimals. That's why you did the R. Okay? I don't know. Like 3rd grade, I think. Maybe? No. Then you got into 4th and 5th grade and you learned decimals. Okay? So we know decimals now. So we're not going to do R7. And we're not going to do 0.7. You know, I get that a lot too. People get the remainder and then they think, okay, that's just the decimal, 0.7. No, we're going to add a decimal 0 and we're going to keep going a couple times. Make sure you carry your decimal directly above, okay, where you put it. So 8 goes into 70. 8 times 8 is 64. Subtract, we get a 6. We're going to keep going. It's all right. It's only going to go a couple places. 8 into 60 goes 7. That's 56. One more time, I think we'll have it. 5 times, and it goes evenly, so we know that we are finished. And so you can just put it as 6.875. Am I finished? Nope. Double check part 2. A negative divided by a negative is a positive. Okay? Let me ask you a question. What if this were like 0.25 divided into 5.5? You would bounce it over twice? Well, when I bounce it over twice, there's nothing here. Okay, so y'all are too smart for me. Okay? Any questions on that? What if, let me just ask, what if you have something like this, and I don't know if I can get a good example of it or not, but let me just say this. What do you know, like, let's say, and this is going to be completely wrong, so I can make sure I get my numbers right. 0. Okay, what if I take this into it, and it's goes in one time, and that's a 6, and I get a remainder, and just say, I know it's remainder 4, and you get 40, and I know 6 can go into 40, so I know that. Yes? Okay, hold on just a second, and then let me show you this. Let's just say, like, what if I bring this down, and 6 goes into 0, but 6 can't go into 0? And let's say I have a 7 next. What do I put right here? We put a 0 right there. Does that make sense? And then you keep going, and then 6 can go into 7 one time. Does that make sense? It was a really bad example, and I know it doesn't work out that way, but just what I'm trying to show you really quickly is if for some reason, whatever you drop down, it can't go into it, you have to accommodate and put a 0 up in that place. Does that make sense? And then keep going, okay? Because you might see one like that on your examples. All right, so what I would like for you to do is on page P19, I want you to do 1 through 49 odd. And I'll pop back to that in 2 seconds.